All right. Skipping 5, 6, 7, and 8, because I haven't done them yet, but I will come back to them. Advent of Code 2024, Day 9, Disk Fragmenter. Good news, nothing tricky yet, says Smab. Good. Another push of the button leaves you in the familiar hallways of some friendly amphipods. What's that from? 2021, Day 23. Ooh. Good thing you each somehow get your own personal mini submarine. The historians jet away in search of the chief, mostly by driving directly into walls. Brilliant. While the historians quickly figure out how to pilot these things, you notice the amphipod in the corner struggling with his computer. He's trying to make more contiguous free space by compacting all the files. But his program isn't working. You offer to help. He shows you the disk map, your puzzle input. It's already generated. For example, this big number. The disk map uses a dense format to represent the layout of files and free space on the disk. The digits alternate between indicating the length of a file and length of free space. Oh, okay. That makes sense. All right, so 2, what is these numbers here? Each file on disk has an ID number. Got it. They appear before they are rearranged, starting with ID 0. So disk map 1, 2, 3, 4, 5 has a ID 0, a 3-block file with ID. Okay, I understand this. I understand what's going on here. They would like to move the blocks one at a time from the leftmost free space block. So you're going to basically reverse the order of the blocks. Okay. And then you compact it this way. I see. And then we do a file system checksum. What is that? The calculate checksum add the result of multiplying each of these blocks positions with the file ID number it contains. Oh, okay. Yeah. So it's just multiply the index by the file number and sum them up. Okay, that you can do that in one line in Rust, right? What is the resulting files checksum? Be careful, copy pasting the input for this puzzle is a single very long line. Ooh, we're about to do this. Get input 2024. So the way my get input thing works is it gets the input and then it does a head on it, showing the first 20 lines, like it did here for day 4. And then, yeah, so if there's only one line, very long line, it's going to blast the whole thing out. Let's see what it looks like. All right, yeah, so it's one long line. There's one line here, and that's the file name. Wow. Let's see what it is in terms of 20,000 characters long. Okay, and that probably includes a new line, maybe not. Yes, that includes a new line. So it's probably, well, it's 19,999. Okay. All right. This should be straightforward, at least for part 1. If we just save one ginormous vector, only 20,000. How bad could it be, right? So let's call it memory. Well, disk, right? So it's a vec of, you know what? I don't know what part 2 is going to be. So let's just store it as a vec of char and we can convert it in part 1. What I was thinking was just dump the whole disk out. But I don't want to do that just yet without knowing what part 2 is, because I don't know what part 2 could be. Maybe part 2 would be like, okay, this is one long 20,000 line thing, but it repeats, a million times. So now you have to figure out a smarter way of doing it. So just self disk equals, gonna get the line, self let line equals, I wonder if AOC lib read, if I have a read, read single line. Look at that. So I should actually be able to do it this way. chars collect. Oops. Oh, it's already vec char. Okay. I thought it was going to be a string, but it's a vec char. So look at that. I already have a thing for it. So now what we'll do is we'll break down the disk here. Let mut disk equals vec new. And this will just be the entire thing. Oh, yeah, this shows single digits, right? But there's a million file numbers, right? So we have to start with the let mut file number equals 0. We're going to start with 0. Let's actually, again, I'm going to use a non-rusty solution here, and I'll use -1 to indicate free space and the file number to indicate the file that's there. So we'll say let iter equals self disk iter while let some file len, right? We start off with file length and then we have a gap. Okay, so while it is iter next, if we have something, then what we'll do is we'll say disk extend vec bang file no semicolon file len, and then we'll increment the file number. Then the next thing has to be a gap. So let's see if there's a gap. If let some gap is equal to iter next. Oh wait, this is going to be a char, so we have to convert it. Let len is equal to file len as u8 minus b like that, and then this has to be as usize, right? Does that compile? Oh no, got the wrong thing here. As usize, there we go. Len as usize. That has to be mutable. Okay, so that compiles, and then the gap is just disk extend vec bang -1 semicolon gap. Oh, we have to do the same thing here. It's usize. Yeah, there's no reason to have two separate variables. Let's just call this len. Okay, and then all we need to do is start processing it. So we're going to do it from the back, right? So we move the file blocks one at a time from the back. So what we'll do is we'll search forward for a gap while let some free space is equal to disk iter position ch, no, val equals -1. This should be the index of where there's a -1. So now we just need to pop something off the back. While let, oh, let's do it this way, loop. Maybe I can clean it up in a bit. We'll say pop equals disk memory. Oh no, disk pop self. This is all self. Oh no, I've converted to local. Yeah. And then if val is equal to -1, we continue. Yeah, so we could do that. While let some val equals disk pop. If val equals -1, continue. We do want to make sure that we didn't just pop off into the gap we found. So we'll need to say if free space is greater than or equal to disk len, right? If we pop too much, then we're going to break out of this while loop. And then this should fail because there won't be any more negative ones because we just popped it off. Oh, it means we have to push it back on, right? Because we just popped off an actual value that we need there. So disk push val and break. Okay, so now we found the spot. So we say disk at free space is equal to val. And we can continue. Oh, no, we want to break out of this loop now. This seems awkward. This doesn't seem like a good approach. There's got to be some cleaner way to do this. Oh, we have unsolved. Oh, it took 3 seconds to run. But now we can add everything up. So it's just disk iter. There shouldn't be any negative ones left on there because we would have popped them off the back. So we can just say map. Oh, we need the position for each one, and it starts at 0. Yes. Yes, 0 times 0. So we start off at 0 and then go to 1, then 2, then 3. Okay, so enumerate works fine. So the index and the value, and then we'll just say index as I64 times val, and then we say sum I64. 3 seconds later, we have a ginormous number, and it is, yay, that's the right answer. Okay. This is good. It's a very slow solution, unfortunately, but it does the trick. I can live with it, but the only problem is, if part 2 now. If part 2 is slow also, then... All right, we'll see. Git add source, git commit. Oh, we've got to do the status. Git commit -m 2024 day 9 part 1. Okay, let's see what part 2 is. Upon completion, 2 things immediately become clear. First, the disk definitely has a lot more contiguous free space, just like the amphipod had hoped. Second, the computer is running much more slowly. Maybe introducing all that file system fragmentation was a bad idea. Yeah, especially when you're flipping the blocks around, right? If these are already in order, and then you make them backwards, and then you try to read the file serially, you have to read backwards. The eager amphipod already has a new plan. Rather than move individual blocks, he'd like to try compacting the files on his disk by moving whole files instead. Oh, interesting. This time, attempt to move the whole files to the leftmost span of free space blocks that could fit the file. Attempt to move each file exactly once in order of decreasing file ID number, starting with the file with the highest file ID number. Okay, yeah, starting from the end. Okay. There's no open span of free space to the left of a file that is large enough to fit the file does not move. Oh, but you keep going, right? You keep finding the other, okay. The first example from above now proceeds differently. So 99 fits in here. 888 doesn't move because there's no gap of 4. 777 moves into this gap of 3. 6666 can't fit. 5 can't. 4 fits here, and then 3 doesn't move because this. Oh, it only moves backwards. Okay, right? Because the 3s could fit here. The 5s and 6s could fit here if you wanted to compact the space, right? But it only moves backwards. Okay. Process of updating the file system checksum is the same now. This example's checksum would be 2858. Start over. All right. I'm glad I split it up the way I did that. I don't know what made me do that, but that was lucky guess, I guess. That all we're doing is storing the disk info, and we're not storing the whole thing this way. Okay, so how do we do this? What I can do is write a test, because that's the first thing I want to do, because this seems a little harder. I don't want to store the memory. I don't want to store the file system the same way. Test part 2. So what you can do is say let mut AOC equals AOC 2024-09 default. AOC, what do I call it? Memory equals this chars collect. So that should test. Oh, it's not called memory. What do I call it? Disk. All right. So what we can do now, I guess what we can do is say assert EQ bang. What was it? 2858? Yeah, 2858 comma AOC. Oh, yeah, I wanted to call part 2, but part 2 returns a vec of string. So I'd have to say this, let answer is equal to vec bang of 2858 to string. Answer. Yeah, we can call it expected. Part 2. I think I can do it that way. And right now it's just returning unsolved. So I obviously don't want to store it the same way because I was storing as individual blocks. So now I want to store it as files. So we need to know the file's number. We need to know the file's length. And for gaps, we need to know the start and the length of each gap. So we need the same kind of information for both. So what we can do is store locations of all that information and then see if we can use that to process where everything goes. So let's start again with the file number, starting at 0. We will loop over while let sum len is equal to, oh yeah, I need the iterator. Let mut iter equals self disk iter. Iter next. So while we have a file, what I'm going to do is I'll store in 2 vectors. Let's mut file list equals vec new, and let mut gap list equals vec new. And that way, what we can do actually vec dec, because I want to pull off the. I want to search. No, that's right. It can be a vec. Because what I'll do is I'll search forward in the gap list for a gap that's big enough. If there is a gap big enough, then I'll reset the file list start point to that start point and then remove that from the gap list. That should work. So we say file list push. We're going to push the tuple of the position we're at right now, which I don't know. Let pause equals 0. Pause. And the number of the file no. And then we'll say file no plus equals 1, position plus equals len. Oh. We need the position, the length, and the file. And then what we can do is say if let sum gap is equal to iter next. And we'll say gap list push pause len. That's all we need. Oh, pause gap. We don't need to know the file number of the gap because there is no file number of the gap. And then pause plus equals gap. Okay. Oh. Oh, right. What if I convert this instead of chars? Let's refactor this to a set of I64s maybe. What was I using here? Oh, it's usizes. Let's do usizes. That way I don't have to do anything fancy. So we can do read single line. Say let disk equals this. Let's call it line so I don't get all messed up, and then just say self disk is equal to line iter map ch, and this will be ch as u8 minus 0 as usize. Collect. And now I have to change part 1. Oh, like that. Okay. And then this, we don't have to worry about it because now len is already a usize, a reference to a usize. Okay. So we can just say star len here. We can get rid of that and say star gap here. And hopefully that doesn't change my answer for part 1. Oh, right. It does change this thing though. Is chars map ch as u8 minus b0 as usize. This is unfortunate based on the way I have my code. Collect. There. Okay. That should hopefully simplifies things a little bit because I don't have to convert anything. So we now have something that actually runs, and I actually have something here called unsolved. So what I want to do is print out for now the file list and the gap list and see what these look like. Oops. Very silly. All right, so we have a file that starts at 0, a file number 0, and it's too long. Then we have a gap of 3, which starts at 3. No, it starts at 2 and is 3 long, right? Right. And then starting at position 5, we have a file of length 3 with 1. Okay, I think this is it. So now we just need to pop the last one off the file list or look at the last one. Can I get that? Zoop. Let last is equal to file list last. Unwrap. Yes. And now we're going to search forward in the gap list to see I in 0 dot dot gap list len. If gap list, gap list of I dot, and the length is here, gap is greater than or equal to last of length, which is 1. Oh, I said gap. I should make these structs so I don't have to mess around with this. Then what we can do is we can reset the file lists. Oh, and then we need to insert it. I think we can do that. Let file equals file list pop unwrap. And then we reset the file's position to the gap. 0 is equal to gap list I dot 0. Now we want to save the gap if there's still some left. If gap list I dot 1 is less than file dot length, then gap list I dot 1 minus equals file dot 1. Else it fit exactly. So we can actually say gap list remove I and then break. Cannot mutate immutable variable. And oh yeah, and then the other thing is we have to put this now back in the file list at the right position. Actually, does it matter? We can sort later. Oh, it does matter because we don't, because we're popping off the end. But we only want to move once, right? That's what it said. Moving whole files instead, decreasing file ID number, starting with the file with the highest file ID number. I thought it said only moving it only once. Why do I remember reading that? Oh yeah, here it is. Attempt to move each file exactly once in order of decreasing file ID number. So I suppose I could change it in place and then resort based on position. But it might be just easier to find the right position in the file list. So we can say here, we've popped it off. How do we know when we found the last file? Oh, I guess, yeah. So attempt to move only once means, oh, yeah, that's the other thing is we have to make sure that this position is less than the file list's position. We need to know that we're moving it backwards. If we can't move it backwards, then we have to give up. If gap list I.0 is greater than or equal to, right, file last.0, break. But we do need a stopping condition. You know what I do is I will push this onto the front. Oh, I can't do this because we're working backwards. And we actually we can't just pop, because what if this doesn't move? We don't want to try it over and over and over again. That's an infinite loop. We actually have to find the previous one. Okay. So we basically want to iter rev, right? Let file equals file list iter rev. Oh, but I can't do that and modify the file list at the same time. Let's say we'll create a new one. Mut updated files equals vec new, and then we can sort that. Okay, this one's a tougher one, isn't it? For file in this, and now we'll look at the file to see if we can move it backwards, and if we can, move it backwards, then we will, and we'll stick in the updated files. If can't, then we'll just stick it in the updated files unchanged. So updated files push file. Can I say copy that? Yeah, try that. And then here, we don't need to do that. We just change that part and say updated files push file. Ugh. And then we do this, and we do this, and we do this, and we break because we found a spot for it. And then once we're done with all of the files, updated files should have, because we either come, if we can't move it backwards, then we're done. If it fits, then we can move it. If it doesn't fit, we can continue. But then we do need to do something with it here. If nothing fit, all right. I'll let moved equals false, moved equals true, or yeah, moved equals true, right? And then moved equals true. And then here, if we didn't move it, then just put it on the updated files push file. All right, so I'm going to quit out of this because I don't know if it's going to be an infinite loop. It shouldn't be, because it's just 2 for loops. Oops. I can't do that on that. Oh, I have to iter mute. No, it's mutable. Oh, I called this last. Okay, file here and file here. Okay, that fixes those. So we can't use minus equals on type usize. Can I do it here? Cannot assign to file 0, which is behind. Oh, because, okay, so we can say while some file equals file list pop. All right, now we should have a, wait a minute. Oh, interesting. File data? I didn't realize, no, oh, while let. Yeah, there's something weird about that macro thing. Okay, so now we have that. So we don't need to push that. We don't need to push that. We don't need to push that. Okay, and now we have this problem here. Cannot assign to file 0 because it's not mutable. And then we still can't borrow data, and we can't use that on type asterisk or ampersand usize. It's a reference to a usize. What? The what? I guess we can just force it, right? We can just say let mut gap equals gap list of I, and then say gap dot 1 minus equals file 1. Can I do that? And then just assign it gap? That's kind of awkward. It's still, oh, because it's I didn't realize I had done that. Okay, there. That was the problem. So I can still do this. Dot 1 and then file dot 1. And then dereferencing the borrow. Okay, cargo run, cargo test. Oh, it's still unsolved because I never did it. Okay, so now it actually ran, right? It ran to completion. We have no idea what things look like. So we can print lin. The file list is empty, but we can print updated files, right? And see if things moved. Println file list. And see if it matches. Yeah, I guess I can run this in Bacon now. Okay, so what do we have? Oh yeah, I need to sort by updated files. Sort by, is it sort by or sort by something? There's another sort by, isn't there? Sort by key. File. And then we're going to sort by the position, which is 1. No. 0. Yeah, that's why it should be a struct. Right? Yeah, the position is 0. Okay. So that stays in one spot. The 9s went here. Uh-oh. There should be a 2 here, and there isn't. It says 5, 3, 1. We got one of them in the right spot. And then the 7s, right? This was here. So it just didn't move the 2. The 7s, and then, oh, the 2 ended up here. Oh, I wonder if I miscalculated this bit here. Maybe it thinks it used up all of it. It definitely says 2, 2. So there should be a gap of 1. Let me print out after each move, each gap, or the gap list. Println found gap for file gap list of I. So it's not finding the 2. And are these the only ones that we moved? Just those 9, 7, and 4 got moved, right? Yes, 4 moves, 7 moved, but the rest stays the same. Okay, we just need to figure out why 2 didn't get a chance to move, because there's definitely a gap there. We're gonna if, okay. Oh, I said greater than or equal to file 0. Yeah, oh, yeah, that's for the position. That's for the position. Okay. Here, the gap list of 1 is greater than or equal to file 1. Okay, so now we can say the new gap list, println gaps, gap list. And we can see what the gap list looks like. Oh. It starts off looking like this: 2, 3, 8, 3, 12, 3. 2, 3, then 8, 3, and 12, 3, right? After we insert the 9, 9, we have 8, 3. Okay, so that means we're not doing this right. If gap list 1 is less than the file 1, oh, minus equals. Ah. Okay. So now the final answer is zeros. The 0 goes there, then 2 9s. Then, nope, that wasn't good enough. It's still just removing that gap. Huh. It says found gap 2, 3, position 2, length 3 for file 429. And we subtract 2 from that, and it should just update the gap list. Okay. King gap by file 1. It's not coming through there. Wait, gap, found gap. Yeah. So here's gap list I of 1. Did I modify gap? No. I modified it here, but I didn't modify it anywhere else. This is bad. Gap list I of 1, file 1. Oh, if it's greater than. Wow, that was painful. All right. Yeah, and then 1, 2, 3 1s. Yep. And then 3 7s, 2 4s, 3 3s. We have the 5s, the 6s, and the 8s. Okay. So now we need to, now that we can do that, we should be able to compute the final score. Let's get rid of all these lines here. You don't need any of that. Okay, so we should still be solving it. Now that we've sorted everything, we need to, what do we do? Oh, this shouldn't be too bad. We should be able to say, let total, I'm going to just do it separately for now, and then we can move it into the output call if we need to. Updated files, iter, map. We're going to get the position and the length and the file now. And what are we going to do with those? We're going to use that, and then we're going to sum that up. I64, and then this is just total. So in here, we're going to loop over the len, starting at the position, and multiply by file no. So it's position dot position dot len plus len map index times file no sum I64. Wow, that's pretty ugly looking, huh? We can't add those. This is a U size, and this is a, oh, okay. We do this, we do this. Index is a U size, file no is, oh, okay, I should be doing it. I'm so used to using I64s for all my stuff. Oh, look at that. We're off by 4. Dang it. Okay. Let's find out what that is. Println. Pause. Len. File no. And we'll see which one we got wrong here. Val. All right, so 020 is 0, right? So this should be 2 times 9 plus 3 times 9, or 5 times 9, which is 45, right? This should be 2 times 4, which is 8. Oh. Oh. The position didn't update. That should be position 4. Why did this not work? Let's see what this says. So it moved 2 from 11 to 2. Why did it move it to 2 if the gap is... Oh, the gap... Oh. Yeah, that's what I forgot. I forgot to increment this by the length of the file. Gap. So let's do that. Gap list I. I checked that the file step was right, but I didn't check this stuff. Plus equals file 1. There we go. Okay, so that was that bug. Let's get rid of this thing here. And let's see if this actually runs. Yeah, it takes a long time. Whoa. The answer is there somewhere. It's a different number. It's a lot faster. That's interesting. It's a lot faster. Yay, that's the right answer. How about that? I'm excited. I'm very excited about that.